Hello, this video is about finding rational zeros to polynomials. And basically it's going to cover Chapter 5, Section 6, Examples 1 and 2. So in the previous lesson, you were able to factor polynomials because you were given a known factor. You were given a polynomial, and then I said something like 2 is a 0, and then you use synthetic division. In this lesson, you will learn how to factor even if you don't have a known factor. So for example, if I asked you to factor this polynomial, y equals x cubed plus x squared minus 3x minus 6, you could try, but you'd get stuck because there's no way to group it and there's no GCF. So in the way that it stands, it's not factorable. If I told you a 0, then you could use synthetic division to find factors and solve for the other zeros, just like you did in the last section. But I didn't give you a 0. So in this section, what we're going to learn how to do is we're going to learn how to find all the possible zeros. Then we're going to guess and check from that list that we establish and use synthetic division to find factors. And once we find a factor, then we're going to use the synthetic division to factor and to find all the zeros. So let's start with how to list possible factors. So there is a thing called the rational zero theorem, and it states that if a polynomial has integer coefficients, meaning positive and negative whole numbers, then every rational zero of the polynomial will be in this form. So there can be irrational zeros, those are ones that would have like square roots, but all the rational ones will be in this form. And that form would be a factor of the constant term. And recall that this is our constant term. And that would be divided by a factor of the leading coefficient. And recall that this is the leading coefficient. Okay, so if we go back to our list right here, we're going to list all the possible zeros. We're going to guess and check with synthetic division to find factors. For this problem, all we're going to do to start is just list all the possible zeros. So we know that the factors of the constant term are the factors of the number 6. So that's going to be 1, 2, 3, and 6. And it's also -1, -2, -3, and -6. Because -1 times positive 6 will give me -6. 1 time, etc., etc., etc. Usually we just write them with plus minus. The factors of the leading coefficient, luckily, our leading coefficient is just 1. Should have drawn that down there. Our leading coefficient is just 1, which means the factors of 1 are either 1 and 1 or -1 and -1. So we would say plus or minus 1. All right, then we're going to make this fraction, so P divided by Q. All of the possible options are going to be the values of P divided by the values of Q. So the value of P was plus or minus 1. The values of Q are plus or minus 1. the value of P was plus or minus 2. The value of Q was plus or minus 1. The value of P is plus or minus 3. The value of Q was plus or minus 1. And hopefully you are seeing a pattern. Obviously, if the value of Q is just 1, it's going to be easier to find these values because they just end up being plus or minus 1, plus or minus 2, plus or minus 3, and then plus or minus 6. Okay, so we have listed all of the possible factors that could be zeros for our polynomial. All right, let's do another example where we're just going to list the possible zeros. So our directions would say list possible zeros, and our example will be f of x equals 2x cubed plus 7x squared minus 4x plus 8. Okay, here P, the constant is 8. So the factors of 8 are going to be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. By the way, when I say factors, I mean all of the numbers that multiply together to give me 8. For the leading coefficient, the factors are plus or minus 1 and plus or minus 2. So when we put our list of possible zeros together, we're going to have everything that's in this list divided by 1, as well as everything that's in this list divided by 2. But what you'll find out is many of those end up being the same values. So we're going to have plus or minus 1 divided by 1, plus or minus 2 divided by 1, plus or minus 4 divided by 1, plus or minus 8 divided by 1, but also plus or minus 1 divided by plus or minus 2. By the way, all of these ones should have been plus or minus. Then we would have plus or minus 2 divided by plus or minus 2. But what is that actually going to be? That ends up being the same as this value. Then we would have plus or minus 4 divided by plus or minus 2. What is that? Hey, that ends up being this value. And lastly, we would have plus or minus 8 divided by plus or minus 2, which A ends up being this value. So when we're listing our values, what we actually have are plus or minus 1/2, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. So those are all of the possible zeros, all the possible real zeros for this example. Go ahead and try these on your own, and you can pause the video here to see if you can test yourself. Okay, you can see the solutions here. On the left, we've got all of the possible solutions, all the possible zeros, all the possible roots for this function. And on the right here in red, again, all of the possible roots, zeros, solutions for this function. Okay, great. Go try it on your own.